As we have just learned, a kick is the flow of formation fluids into the wellbore. Taking a kick means that primary well control has been lost, and appropriate first actions must be taken in order to regain control of the well. Normally, this would mean closing a blowout preventer and is known as secondary well control. Therefore, all well control equipment must be in perfect working order and the crew fully trained and competent in its use. A kick can occur for a number of reasons. For example, abnormal formation pressure, failure to monitor the well, failure to keep the well full of mud, incorrect fluid density, swabbing while tripping, and lost circulation. Let's take a closer look at each of these. One of the most common causes of kicks is drilling unexpectedly into an abnormally pressured area of formation. This pressure may be greater than that exerted by the drilling fluid, and this will result in a kick. Throughout the drilling operations, the well has to be monitored at all times. Failure to do so may mean that an early indication of influx of formation fluids and a well kick could be easily missed, and so the opportunity to take fast, effective action is lost. Failure to keep the well full occurs when all of the drill string is being removed from the well and the level of the drilling fluid goes down. The space left by the drill string being removed has to be constantly replaced by drilling fluid. If this doesn't happen, then the column of fluid decreases, and so the pressure exerted at the bottom of the well is reduced and potentially causes a kick. The weight or density of the drilling fluid is restricted to the minimum necessary for well control and wellbore stability, and so is constantly checked throughout the drilling operation using a mud balance. If the weight is too great, it may damage or fracture the formation. If the mud weight is not sufficient, then the well may become underbalanced, potentially resulting in a kick. Swabbing is caused by the reduction in bottom hole pressure when the drill string is pulled out of the well. An analogy is the effect of a piston in a cylinder. This results in a decrease in bottom hole pressure. If this reduction in pressure is large enough, bottom hole pressure could drop below formation pressure, allowing formation fluids to flow into the wellbore, in other words, a kick. The expansion of a gas bubble moving up the well further reduces hydrostatic pressure. Lost circulation occurs as the drilling fluid is being circulated down the drill string and back up through the annulus to the mud pits, and the level of fluid goes down. This is because the drilling fluid is being lost to the formation in the open hole section of the well. Sometimes it will only be partial loss circulation, or it can be a complete loss of drilling fluid, or total losses. If it is not possible to keep the hole full of mud, bottom hole pressure will be reduced, potentially leading to a kick.